At a mining site in Pakistan, a mining loader's rear axle brake system severely failed due to continuous overload operation. However, behind a desperate situation, a group of professional repair technicians worked seamlessly together, breaking conventional methods and showcasing a technical miracle. Their tasks were clearly defined. One technician focused on dismantling the tires, while another simultaneously drained the gear oil from the rear axle. This coordinated teamwork significantly sped up the repair process. Amidst such massive equipment, humans appeared relatively small, especially during the tire removal process, which looked very dangerous and was in fact not safe at all. The same applied to the rear axle, which alone weighed several tons. For safety reasons, the technicians had to secure it with steel wire ropes and then use the loader to lift it. They only dared remove the bolts supporting the rear axle after ensuring it was secure. Then, they carefully lowered it to the ground using the loader. And finally, they used the loader's strength to drag the rear axle to an open area, making it easier for the next disassembly steps. Using hand tools, the technicians meticulously dismantled the wet brake system. As they disassembled it, they carefully cleaned the accumulated sludge, ensuring every detail was spotless. Although they lacked the convenience of electric or pneumatic tools, the technicians' diligent hands exhibited incredible strength and skill. The technicians disassembled the wet brake system and removed all the connecting bolts. This task, while seemingly simple, involved a complex structure. Steel plates, friction plates, and planetary gears intertwined inside the reducer, forming the core of the entire braking system. After a thorough inspection, the issue was evident. The friction plates were nearly worn out, and the steel plates were severely scratched. Under these circumstances, the most reasonable solution would be to replace the friction and steel plates. However, considering the repair costs, the technicians decided to try restoring these parts with their skills. The damaged steel plates were brought to the shop and fixed on a lathe, where an angle grinder was used to manually smooth the damaged surfaces, making them look as good as new. The technicians employed an advanced turning technique with a lathe tool for the more severely worn steel plates. After these meticulous processes, the steel plates were flat, smooth, and shining like new. Before reassembly, the technicians carefully cleaned each component with gasoline, ensuring it was spotless. After a thorough cleaning, the parts looked almost brand new. Since the original sealing rings were severely aged, the technicians decided to replace all the seals with new ones to prevent future oil leakage or pressure loss. This decision demonstrated their long-term consideration for the repair, ensuring that the current problem was fixed and that the assembled parts would remain stable for extended periods. Next, the technicians reinstalled the repaired steel plates. Before installation, they first applied some gear oil to ensure proper lubrication. They then carefully installed the steel plates. Although the friction plates couldn't be repaired, the technicians replaced them with brand new parts to ensure the system's proper operation. Though seemingly simple, the installation process was a critical task in the repair field, where details determine success or failure. When assembling the parts, the technicians applied sealing glue, a crucial step to prevent system leaks. Every action taken by the technicians was well thought out, as they knew every detail would affect the overall stability and reliability. During reassembly, they adhered to the principle of disassembling first and reassembling in reverse order, maintaining continuity and safety throughout the repair process. After assembling the rear axle, the next crucial step was reinstalling it onto the loader, which again required the loader's assistance. Installing the rear axle was a skill that needed to be done while ensuring stability. The technicians understood the importance of this process, requiring precise actions and coordinated efforts. They employed various techniques to ensure safety and efficiency when installing the rear axle. First, they placed the bracket bolts back in their original positions without tightening them. This step was to facilitate the subsequent installation of other screws. After all the screws were correctly placed, the technicians gradually tightened them, ensuring each screw was adequately positioned. Then, the technicians focused on installing the tires, which also required another loader to assist in lifting the tires. The technicians then pushed the tires back into place, ensuring they were perfectly aligned with the rear axle. The technicians manually secured the screws to fix the tires in place. This process, though seemingly tedious, was filled with skill. Every screw needed careful adjustment to ensure the tires were tightly secured, preventing any looseness. After a series of precise operations, the mining loader was finally repaired. This seemingly simple repair process was, in fact, the culmination of decades of accumulated skills and experience, highlighting the technicians' deep respect for mechanical repair and their professional spirit.